In this video, we're continue working on topic 8.4, where we're looking at the area between two regions horizontally. So this time we're going to see that our graphs actually intersect. So let's take and graph each one of these things, and then because we're supposed to find the area and then sketch it and shade it to help us understand this. So this is an upside down parabola with a y-intercept of 2. So it's going to look something like this. It's going to go up. I don't know exactly where it's going to land upside down, but we know it's going to cross about square root of 2, which we know is more than 1. So we're going to plop it kind of in there. So you know it's upside down like that somehow. Then it looks like this one here, I'm going to do in blue. It looks like we need to graph the line y equals x. So I'm going to start at the y-intercept and go up 1 over 1, down 1 over 1. It looks like I didn't quite draw this one quite far enough. Let me draw that a little bit more. So we know we've got 2 points of intersection. So we need to actually calculate those points of intersection and figure out what they are. I may have gotten close on my graph. I don't know. So to find points of intersection, we're going to set the two functions equal to each other. It's quadratic looking, so that means I need to get it equal to 0. Since there's a negative lead coefficient, I'm going to move them to the right. So 0 equals x squared plus x minus 2. I'm going to now do a good old magic x. We need two numbers that multiply to negative 2 and add to 1. So that would be 2 and negative 1. So I've got 0 equals x plus 2 times x minus 1. I'm going to use zero product property to solve that. So x plus 2 equals 0 and x minus 1 equals 0. I apologize for the extra noise. X equals 2 and x equals 1. So those are the bounds. And I got pretty close. Like that was the negative 2. That's the 1. I got pretty close in my sketch. All right, so now we actually have to do the area. We haven't calculated that yet. So I know I'm going to integrate from negative 2 to 1. Always want my smaller one first. Of my top function, which is the purple function, which was the 2 minus x squared. And then I'm going to subtract, and it's always a subtract. I'm going to subtract my blue function, which was x. And then, of course, we always put a dx after it. So I'm going to integrate it. I really don't need as many parentheses as what I had there. So when I integrate 2, I get 2x. When I integrate x squared, I get negative x cubed over 3. When I integrate x, I get negative x squared over 2. And then I'm going to go from negative 2 to 1. We're going to go ahead and substitute our values in there. So I'm going to do 2 times 1 is 2. 1 cubed is 1, so it's minus 1/3. 1 squared is 1, so it'd be minus 1/2. And then I'm going to subtract. It's always a subtract, and I'm always going to draw parentheses. And then we're going to put the negative 2 in. So 2 times negative 2 would be negative 4. Negative 2 cubed would be negative 8, and there was already a negative hanging out there. That's going to go positive. And then there's a minus, and then negative 2 squared would be 4 over 2. Now, sometimes I don't reduce things right away. So this is kind of one of the tricks that I use when I am doing this type of problem. I try to combine like terms with what I have, but I'm noticing a negative there. And so it means I'm going to distribute that in, and I'm going to so I'm swapping all of my signs. And then notice I've got like terms here. So 2 plus 4 is 6. Negative 1/3 and negative 8/3 is negative 9/3. And then negative 1/2 and positive 4/2 is positive 3/2. I know that this reduces to 3. So I have 6 minus 3 plus 3/2. 6 minus 3 is 3 plus 3/2. 3 and halves would be 6/2 plus 9/2, plus 3/2 equals 9/2.